Hi everybody, my name is Emily Fairless, and I just wanted to kind of touch base with you guys on the section of big picture in regard to rhabdomyolysis. I thought this would be a really good point to kind of do a video to just kind of go over everything in terms of whether or not rhabdomyolysis is a adaptive response and what occurs in rhabdomyolysis if that is our body's way of trying to adapt. And I do think it is, and so I just kind of wanted to explain why versus just writing it all down. I thought this might be a little bit of a more fun way to do it. So just to review, rhabdomyolysis again occurs when skeletal muscle is broken down and the skeletal muscle will release its contents into the extracellular space. So how does this occur? Again, if you read through the wiki page, there are several different ways that rhabdomyolysis can occur. Some of those include trauma, for example, such as a crushing injury. I discussed an example of a earthquake where people are crushed underneath the debris, and that compression injury, that compression on the skeletal muscle can end up causing rhabdomyolysis. Additionally, drugs. Drugs have been shown, certain prescription drugs, illegal drugs such as cocaine, have been shown to cause rhabdomyolysis. Strenuous exercise can lead to rhabdomyolysis, especially when it is very hot and humid outside, as well as when the individual who is exercising is untrained and not used to that heavy stressor on the body. Additionally, one other way that I just put down here, but again, there are several others as well as infection. Infection can end up leading to rhabdomyolysis. So what happens? First, when the skeletal muscle gets damaged, it is going to release its contents into the extracellular space. So what's important is that we understand which ions were in the intracellular space and which were in the extracellular space, and kind of what ends up shifting as a result of everything kind of getting released. So myoglobin, which holds oxygen, and is stored in the skeletal muscle. When it's released, when the skeletal muscle breaks down, that will get released then into the extracellular space. Creatine phosphate kinase is also something that is found in the cell, in the skeletal muscle, so that will also get released into the extracellular space. Potassium and phosphate are both intracellular ions normally, and so when they are released, they are going to flow into the extracellular space. Again, we need to remember kind of the osmosis, the shifting of ions, and kind of where everything is going to flow. Remember that ions are going to flow from the areas of high concentration to low concentration. So if potassium and phosphate are higher in the cell, in the muscle tissue, then when it's released, it's going to flow out where there's less. So both will flow then into the extracellular space. Sodium is normally a extracellular ion, and so when the skeletal muscle is damaged and the membrane releases, so contents begin to flow out, sodium then is going to flow into the cell because that's where there will be less sodium, so it's going to want to go in. However, the issue that results with rhabdomyolysis is that water follows sodium, and so water is also going to flow into the cell then and can cause swelling. Calcium and chloride both as well will flow into the cell. So with all of the shifting of the ions and water, what is the body's response? That's kind of what this big picture, that's what we're focusing on. And in terms of an adaptive response, this is why I feel that it is an adaptive response. There are specific pathways that happen, so I do feel that it is fact that these things do happen, and it is I feel that they are the adaptive response. So when sodium flows into the cell, water follows the cell, follows sodium. So it will also flow into the cell. What does this mean? This means then the plasma volume decreases. So now we have a lower volume. So what does the body do in response to a low plasma volume? The sympathetic nervous system is activated, ADH, and the renin-angiotensin system are all activated, if we remember from earlier lectures, in an attempt to then try to raise blood volume. And how can we do that? That would be by vasoconstriction. We're trying to increase pressure since volume is decreased to try to maintain homeostasis. Additionally, we have to remember that no matter the type, the mechanism of injury, whether it's from drugs, infection, a crushing injury, something like that, we have damage to skeletal muscle. That is the big part of rhabdomyolysis. That's why it occurs. It's because we have this damaged skeletal tissue that then is releasing its contents into the extracellular space. So what is the response of the body then to damaged tissues is we have the inflammatory response. Neutrophils are going to head towards those tissues. Swelling is going to, even more swelling will result because, again, we have these damaged tissues. The tissues are going to release chemicals, release all those things that we've learned about previously. This whole inflammatory response is going to occur. That is adaptive. Even though it ends up causing further issues, it is our body's attempt to try to counterbalance what occurred and try to maintain homeostasis as much as possible. So we have in our body, if somebody has rhabdomyolysis, all the ions are all now switching from the extracellular space to now intracellular space. We have water flowing into the cells, swelling occurring. We have damaged tissues. So what does our body do? Our body attempts then to vasoconstrict to try to maintain plasma volume, and it's going to follow an inflammatory response to try to help with these damaged tissues. Unfortunately, this then ends up causing additional issues in terms of vasoconstriction because with the myoglobin coming out from the cell, it can go into the renal tubules, which will be vasoconstricted, and then that can cause additional issues with the renal system and lead to renal failure. But overall, it is our body's attempt to try to maintain homeostasis and try to fix what is occurring.